Sir, shall we start? Sir Karthikeyan, sir?
Yeah, we can start. We can start.
Okay, sir. Thank you, sir. Good afternoon. I welcome you all for the 5 days faculty development program on modern development in concrete and construction areas organized by Department of Civil Engineering, Paavai Engineering College, Namakkal. Today's session will be on the topic concrete materials by our speaker Dr. J. Karthikeyan. Dr. J. Karthikeyan obtained his BE Civil Engineering from Kumaraguru College of Technology in 2002, ME Structural Engineering from VLB Johnny ML College of Engineering and Technology in 2004, and PhD Structural Engineering from IIT Roorkee in 2008. At present, he is working as Associate Professor in Department of Civil Engineering, National Institute of Technology, Trichy. He has 11 years of teaching experience. He acted as chairperson and delivered keynote lectures in various conferences and seminars. Among 12 PhD scholars, 5 of them have completed and 7 pursuing their PhD under his guidance. His areas of expertise: high performance concrete pre-stressed concrete bridges. He is an active member in various professional bodies related to structural engineering and materials. He has secured the Young Faculty Award awarded by Venus International Foundation, Chennai, July 2015. He was awarded twice for the International Travel Grant Scheme for Young Scientists awarded by SERB DST, New Delhi during August 2011 and September 2015. He won a national award for the Innovative Students Best Project Award at bachelor's level awarded by Indian National Academy of Engineers, New Delhi. He has been to US, Canada, France, Switzerland, Czech Republic, New Zealand, and Sri Lanka, presented technical papers, visited various universities and professional bodies related towards his profession. He has published nearly 50 research papers in various journals and international conferences. He has a patent on topic, a process for producing concrete that utilizes weld slag as a partial replacement to fine aggregate by blending with fine aggregate in concrete, which was granted on 12th April 2018. Thank you. I welcome you, sir. Listen to Dr. JK, sir.
Yeah, thank you, Professor. And
Okay, sir. Thank you.
uh, so, good afternoon, everybody. So, the topic for the day, which I will be covering for in the next 35 to 40 minute session, is about lightweight concrete, which is one of the special type of concrete. So, what is this lightweight concrete? How it performs? So that basic ideas, fundamental concepts, we will be going in this complete lecture session. How to prepare a lightweight? What are all the chief lightweight materials that can be used? So these things will be there. And before going to it, to know more useful videos and some presentation sessions related to concrete materials, forensic engineering, pre-stress concrete. I have posted few videos in my YouTube channel. Just type my name Karthikeyan space Jayakumar in that, so you can come to my channel, and it will be very useful for the students who really want to know many fundamental part in concrete technology and forensic engineering, pre-stress concrete. So I have uploaded few videos and many more to come. So if anybody is very keen to know more about those topics, you are most welcome to visit my channel, and more updates will be coming in the forthcoming days. So with these few words, I will directly enter into the topic. What is this lightweight concrete? So you know that concrete is mainly classified into three categories. One is the lightweight concrete, normal weight concrete, and heavyweight concrete. So normal weight concrete is the one which we will be using in the traditional constructions, where its density is around 2400 kg per meter cube or 24 kilonewton per meter cube. We use the materials like cement, fine aggregate, coarse aggregate, water, and admixture. If you want, you can use. This is one thing. Now, what is this heavyweight aggregate? Heavyweight aggregate means the density of the aggregate will be very high. Sorry, the density of the concrete will be very high, and these applications for very specialized works, especially for nuclear power plant, for power plant structures and other things, heavyweight concrete will be playing a vital role where this nuclear fusion and fission reaction takes place in by generating this power. So that's why in the nuclear power plants, in order to act, that member should act as a highly radiant shield. Against this radiation, it should act as a shield. So it should not penetrate into your concrete member, thereby it will get cracked later. So in that way, your normal weight concrete and lightweight concrete will not be useful. So in that way, heavyweight concrete is very, very essential, where the density will be more than 3000 kg per meter cube or 30 kilonewton per meter cube. We will be using some steel balls as the coarse aggregate. Thereby we can increase the density of the concrete. The minimum density of the concrete itself will be like 3000 kg per meter cube. So those things is heavyweight concrete. Now lightweight concrete, this is a phenomenon which is straight opposite to all these two factors. The word itself says lightweight concrete. So what is the density range? So the density ranges from 300 kg per meter cube to 1800 kg per meter cube. So whatever that comes in that category, when the density of concrete is between 300 kg per meter cube to 1800 kg per meter cube, then it is classified as lightweight concrete. In this lightweight concrete, you have one as one lightweight concrete can be used as one part can be used as an insulation material. So where the density will not be that much predominant, it will be totally in lighter in weight, where the density will be just only 300 kg, 400 kg, 500, 600, only like that. But if you want to use that lightweight concrete for structures purpose, then it will be classified as structural lightweight concrete, and for that the density should be like varying from 1350, that is 1350 to 1800 kg per meter cube. So one this comes, and when you have a minimum grade as M20, then it is called a structural concrete. Structural lightweight concrete is used, it can be used only for that, for structural purpose, like whatever you are going for a building or any other structures, lightweight structures where you have some reinforced concrete for any structural purpose. Then your grade of concrete should be minimum M20, and your density should no way be less than 1350. It should be above 1350, but it should be limited to 1800 kg per meter cube. These are some general guidelines for structural lightweight concrete. One massive advantage in this is it is of lighter weight, but you cannot expect very high strength. Research is going on to make some high strength lightweight concrete. Up to M60 grade it is achievable, but if you want for something like 100 plus another thing, still there is no proper materials or the methodology that has been coined for that. So achieving M25 M20 grade itself is a more than enough if you maintain a density with this. So how this makes light in weight, that is another one question. It is of the aggregates what you use, because normally for conventional concrete we will be using crushed blue granite stones. Heavyweight concrete you use hematite, and iron ore material, or you use some spherical steel balls in it, so that becomes heavyweight. So that is because of the inbuilt capability of the coarse aggregate material what you use to that concrete. So in that way it categorizes. So here we have to use some lighter weight material. We cannot make cement much lighter, we cannot make sand much lighter, it is impossible. Only thing to make much lighter comparatively with our conventional is our aggregates only. So we got to play over that, and we have to make that density mark to just fit into that category. So what are all that lightweight materials? all materials can be used as coarse aggregate in that lightweight we cannot use. There are certain things. Normally, when you see the guidelines for selection of coarse aggregate material, it will be they will be saying that the aggregate should be tough enough, it should be sound, it should have a good thermal resistance, it should have a very good what to say repellent capacity. It should not absorb more water. So many criteria are there. So it has to bypass all those criteria. That physical characteristics, the dirt should be completely removed. The aggregate should be clean and sound. They used to tell all those things. So what are all the materials that we can make a concrete light, and what are all that lightweight aggregates we will see in the field. So before going to this, see, this is the things whatever I told. If you see in this the first slide, the theoretical portion, that is the one of the advantage using is your dead weight of your structure gets completely down. See, whenever you do some RCC calculation, say your beam size is something like 230 by 500 mm. So that 230 by 500, if you calculate the self weight of the beam 0.23 by zero point 0.5 for 1 meter width into, so when we use RCC structure, you have to multiply it with 25. If it is plain cement concrete, it will be. So if you just roughly calculate it, so let me make it as zero point 0.2 for my convenience. So this roughly comes like one self weight of the beam will be like, if you just multiply it, you will get like 0.01 into 25. If you multiply that, it is 0.25 kilonewton per meter. 0.25 kilonewton per meter means 10 newton is equal to 1 kg approximately. So when you get 1000 newton is equal to 1 kilonewton. Okay, 1000 newton is equal to 1 kilometer. So therefore, what will happen? So if you want this 10 newton is equal to this much of kg, means 1 kilonewton means how much it comes? It comes like something like 250. So 250 kg per meter is your self weight of the beam. But the same thing, if you use lightweight aggregate where it possesses a density, let us say it is 50. So just imagine where will be 250 and where will be 50, 150. So nearly you are getting reduced, 100 kilogram is reduced for that structure unit. So it is very easy to handle also. So this is one idea behind. So this is how you have to categorize the things. So this is the advantage of using lightweight concrete. So thereby whatever it happens, when your member is not much stiffened, if it is more stiff, it will be more prone to the earthquake and other things, because when it is too rigid and other things, when some horizontal excitation comes, that rigid structures will overturn at one point of time. It won't be able to bear that much of huge horizontal excitation like earthquake and other things. So when lightweight structures are there, the overturning moment and everything will be fairly reduced. I'm not telling that it will not fail. It will not at all fail. It will fail, but the life. So just imagine there is an earthquake and a beam or a slab falls on your head. How it will be that impact? So you are getting injured. Something it falls on your legs, or it falls on your shoulders, or something. Some major accident happens, or some portion of your slab pierces and it falls down. So when these things, heavy weights, conventional weight and everything is there, when the dead load is fairly this thing, this can minimize the effect. So that overturning moment and the intimation, the cause of the failure will be apparently reduced. So where this lightweight concrete has had a widespread, where it has come into existence, most of the people from USA, UK and Sweden and few Europe countries, they always use this as a traditional activity. Even in US nowadays, the houses are in lightweight construction. They immediately they plan the things, they orient the building, and they more go for the wooden construction, because since that is more prone to cold areas, they use very lightweight concrete, or mostly they will be using some wooden panels, wooden floors for the house construction. Concrete construction will be very minimal for them. So most of the places they go for only this lightweight component. So this is one aspect. So in the next thing, see, I told about the structural lightweight concrete. So how it can be made? It should be less density. As I told, the density should be within like 1300 to or 1350 to 1800 kg per meter cube. So then only you can categorize this as a structural lightweight concrete. So you have to see that your density of your concrete should be. So here they have given a provision. You can use in combination. You can use some 30% or 20% of your normal weight aggregate in combination with lightweight to achieve this density. It is possible. You cannot use even 100% lightweight material. So that time it might get into 900 kg per meter cube. Means what is the density of water? Density of water is 1000. So when you pour that put that concrete in the water, if it is submerged, it will float on the water. So that is called foam concrete. That is another thing. So we will be seeing in the forthcoming lectures for this. So this is the aspect which you have to keep in mind for structural lightweight concrete. So what are all the probable compressive strength? So if your compressing strength is categorized as say, let me say that you are getting only 0.69 megapascal to 6.89 MPa, that you made a lightweight concrete and you are testing the cube, you are ending up with this. So how will you categorize? You have a density like 450 kg per meter cube. So for example, I'm telling you are getting a strength like 0.69 Newton per mm square to 6.9. So this classification is called as very low density concrete. So when it is between 6.89 to 17.24 MPa, then it is a moderate lightweight strength concrete. When the structural lightweight concrete classifies when it is above 17 MPa. That's why I told the minimum grade of concrete to be for structural lightweight concrete is M20. So that is very important here. You have to keep these things in mind. Then only this classification will serve the purpose. So these are a few lightweight materials which can be used for structural purpose. That is expanded shale, expanded clay, expanded slate, expanded slag. These are all some naturally available materials which possess a density of that concrete between 1350 to 1800 kg per meter cube. So this is the overall density of that lightweight concrete when you use these materials as a porcelain cube. Okay, so this is one thing. This classification is given according to ASTM C330 category. Okay, like how we have IS 4562,000, IS 10262, like that the ASTM classification, ASTM code, American Standards for Testing of Materials. So this is the thing, like how we have Indian standard, this is American. So ACI classifies the lightweight aggregate for structural purpose as this one of the classification. Then how this lightweight concrete can be achieved? So it can be achieved in three different ways. So that way is, first, use normal aggregates, whatever like shale, slate, whatever it is. Buy some cellular porous or lightweight aggregate. You can use that one. You can bring. Then next category, you can introduce air bubble into the mortar, which is called as aerated concrete. Okay, aerated concrete. Then you can completely omit the sand, and you can use coarse aggregate. So that is called as no fines concrete. So these are some possible ways. So how to make this aerated concrete, how to make this foamed concrete, all these things will come in one category. This is in another category. So this is directly, you have certain lightweight aggregates like how you have expanded shale plate, like that you have many categories like that. Whatever that, because it is a naturally available form. In some places you might not have this mineral, this type of aggregate. In some place that aggregate will not be there. Say X aggregate is not there, but Y aggregate will be present. Y type of aggregate will be present. So that, as per the dependence of the place, you can choose that aggregates appropriately. So these are the three different ways you can use. So no fines concrete is very useful for pavement application, especially the water, whatever it gets logged into the pavement surface, then you will get some potholes in your roads. So in order to avoid the potholes in the roads or the damage in the road, they use no fines concrete. have a beautiful video. You can see that in the later part of this lecture. So let me now quickly move on to the next slide. So these are the first category. By using some lightweight aggregates, what are all? So natural lightweight aggregate, artificial lightweight aggregate. Again, it is categorized into two types. So in under this natural aggregate, you have pumice, scoria, rhysus cast, diatomite, volcanic tuff, foamed lava. These are all natural forms. Okay. Artificial lightweight aggregate means we have to manufacture. That is for sintered fly ash, foamed slag, blotted clay, artificial cinder, expanded shale slate, coke breeze, okay, expanded perlite, exfoliated vermiculite. So these are all artificially available materials, lightweight aggregates. These are the types you can use. So one place to other place, volcanic tuff might not be available in one locality, but scoria will be abundantly available. Scoria is nothing but it is obtained in the aquatic plants. It will be in the river beds and the deep sea beds where you can take that. So in the which is in the form of a reef and other things, which will be highly lighter in weight. So those things can be used as an aggregate. They are telling. I'm telling you. So the explanation of each and everything will be shown in the forthcoming slides. See here, the first aggregate is pumice. Pumice is the rock in the volcanic region. So the bulk density of that aggregate will be varying from 500 to 800. So the texture is fairly even texture interconnected with voids. So it is very light colored and nearly white. So this is pumice. Scoria is nothing but the scoria is a lightweight aggregate of the volcanic origin. Again, it is dark in color. I told scoria as aquatic. It is not. Diatomite is from aquatic. What I told in an reversal manner. Actually, diatomite comes in the aquatic. Scoria is coming from only volcanic region. So wherever this volcanoes and other things is there, you can get this. The dry form of that will be so it is simply slightly weaker than pumice. Okay, so that is the property. Then next is rhysus cash. Use of rhysus groundnut husk has been reported as a lightweight aggregate. They have used. Okay, they have, many people have used over because it is very light. The shells and everything is very light. No? So they have used that for the purpose. Next one is the sawdust. Use of the sawdust, that is in the topping of floorings and other things, it is very essential. So that is one thing. Okay, but only thing is the wood that obviously affect the setting and hardening with the Portland cement. That is the only problem. Setting time problem will come when you use directly the wooden material. This is one. The next one is diatomite. Diatomite, as I told, it is from the aquatic plants. Okay, it has a high pozzolanic. It acts as a high pozzolanic material. It is quite microscopic. So this comes from the aquatic plants, very lighter in weight. So these are some natural lightweight aggregates. So this is the photograph showing about pumice and how a scoria look like. Okay, mostly these things are obtained from volcanoes, so that's why you get these sorts of pores and the because of the melting of this molten magma and other things. The next lightweight artificial lightweight aggregate is nothing but sintered pulverized fuel ash, that is the fly ash. So you know how the fly ash is come. You are artificially you are making and you are creating like pellets, small round like pellets. You can manufacture using slag. You can manufacture. So you have some treatment process. So with that you can use blotted clay is available. So that has a tend to expand. So when you are using that for some gas forming agents and other things, it will be very good marine application. And when you use these gas forming agents, especially for aerated concrete, you will be using this gas forming agent. It will act as a gas forming agent. So this is one thing. Blotted clay, since it has an inbuilt like exfoliated vermiculite is also the same thing because they use these things for some fertilizer and animal feeds. As animal feeds, they use this thing as a as a small portion. Okay, so that one also we can use. And then cinders, clinkers, these are all like that. These are all obtained from the coal things only because these are all the various formation of coal. Like how we have Black coal is different, and lignite corporation, lignite is a type of a coal, that is of different parameter. So like that, yeah, the cinders, clinker, breeze, and all is a type of coal. Its performance will be different, and it will be abundantly available in one place over the other place. So this is the sample showing about the exfoliated vermiclay. Then this is a clinker. Okay, this is the expanded clay, shale slate, and also you can use some lightweight glass aggregate. But what I do is you have to be very careful when you use. Normally, I won't give this sort of work to my students, because glass, you have to use some steel gloves and you have to handle. You cannot handle them with your ordinary hands, and you cannot use rubber gloves also. It will tend to tear, it will pierce. So anything happens, it's that. So I am bit reluctant in this. So but when you are using some glass aggregate, you see that there is no reactive silica. If there is some reactive silica, then it will create some durability issue, like you will get some severe alkali aggregate reaction and other things. So you have to take care of that. But glass aggregate, I am highly reluctant. But it is a very good material, very lightweight material. But the handling is the problematic, because some portion of those things get into, or if it tears your fingers, it will create some problem. Even some small glass piece enter into it, which is very very small, in a micro level. If it goes, and it might affect your veins and other things. So that's why I am very reluctant to give it to my students. So these are the various forms of glass. They have sieved it in the different types of sieves. Say from point 0.1 mm to 8 mm sieve. So this is how they have artificially manufactured the glass aggregate. Now with this, when you use these things naturally, what is the thing? The first and foremost, I say, well, with the advantage of using this lightweight aggregate is cost is a good thing. But the lightweight aggregate, when they market, it is very costly. But if you are able to manufacture by your own, it is good. It is very cheap. So that is one thing. Then see, I told, no, one salient point I told about that seismic excitation whenever it has. See here, less dead load. Actually, of course, that is the purpose of using lightweight concrete. But what is this? The improved seismic structural response. So that is a key here. So then, lightweight concrete is having a very good fire resistance. In comparison with your normal weight concrete, lightweight concrete has a very good fire resistance. Because of its lighter in weight, what will happen? It has a very good resistance. It will not burst, because when the toughness of the aggregate is more, and if your coefficient of thermal expansion is quite large for the conventional aggregate, but for these things the coefficient of thermal expansion is very less, so that's why it takes more fire. So this is one advantage. Naturally, building faster building rates, you can erect as quick as possible. The more, the lighter weight. So framed structure, using in framed structure, partition walls and other things, when you use some light materials, it is very very advantage. So this is the main advantage of using the structural lightweight. Otherwise, if you want to go for some overlay, where your dead weight of the structure should not get fairly affected, so for overlaying purpose, you can use a lightweight material. You can use the vermiculate based lightweight concrete to overlay that. Especially for some electrical linings and everything, you want to seal it later, means some additional thing has come. But your dead load of the structure should not get disturbed. So in that way, that 300 kg per meter cube concrete will be very very valuable. So that is what we are talking here. Apart from that, so then the next one disadvantage is it will absorb more water. Lightweight aggregate will absorb more water. Suppose if your water absorption is 0.7% for your conventional aggregate, okay, but for lightweight aggregate, it will even be 28%. It will be 30%. So it can be anywhere. It can be greater than 1.5% to 30%. So you have to take that absorption rate properly, and you have to design it in the design. If you fail to do the water absorption tests, then it is not advisable. It will fairly affect your flowable characteristics of concrete. Then another one important point what they say is you have to increase the cover size when you go for lightweight concrete 10 extra in order to avoid corrosion, because it will be more prone to corrosion, because the surface will be, due to its lighter weight, you will not have a dense thing, the transition zone and other things, that the bonding, it will not be very significant, it will not be highly impermeable. So what you have to do, you have to increase your cover size. Suppose normally if you keep 25 cover size, when you use lightweight aggregate you have to keep 35 or 40 So that is the only thing you have to see. Okay, so these are certain things. See here, lightweight aggregates have hard surface, add pozzolanic materials to improve the versatility. That is, you have to use some chemical admixture, also some mineral admixture to have a. You have to keep your strength intact. Suppose if you want a 30 MPa or 35 MPa strength with lightweight aggregate, the conventional one you cannot achieve. You will get only like 17 MPa or 18 MPa. But if you want 35 MPa, you have to take the help of this pozzolanic materials. Okay, so this is another important parameter which you have to. Then formed concrete. This is the next type. So for this you need a foam generator to mix the things. So you will be using some gas forming agents. You will be creating some air bubbles inside, and it will come like a foam. So this is the thing. So where you can see lots and lots of air voids. Okay. So this is called as the foamed concrete. So if you just put this in the water, or it is called as aerated concrete. Okay. So if you just put in the water, it will float, where the density is very less. It will be just 900 kg per meter cube. That's it. So apart from that, this is about the aerated concrete. See here, 1100. It is not 1100. It will be less than 1000. It should be 900. Then only it will float. If it is 1100 kg, it will not float. So that is one thing. Normally, you will get a strength of 12 to 14 MPa. Only that much for that. Okay, foamed aggregate. So this is the finish of a foamed concrete. Okay. So this is the vermiculite material. So when I use vermiculite, see here I have a lot of my electrical linings, PVC pipes and everything is available here. So I need to seal this. So newly I had created something. So this is my existing floor. So without affecting the dead load, the superimposed dead load should not be very high. So where these things, lightweight aggregate for insulating this thing for purpose, this will play a vital role. So that plays a major significance. So in this way, this lightweight concrete and other things is very useful. Next, no fines concrete. In no fines concrete, what you will be doing is you will not use any fine aggregate. So you will be using the coarse aggregate and cement, where if you pour the water, it will act as a drain. So this will be very useful for the pavement applications. Okay, this is also called as pervious concrete. So these are some innovative applications for pervious concrete, especially for the retaining walls, where the seepage of water and everything is very high. When you use this pervious concrete, it is very impact. So for stormwater drainage or some deep holes, stormwater weeps for stormwater drainage. So these all will be very helpful. Pervious concrete will be very useful. So this is one thing. So this is the video showing about the pervious concrete, which will be a 1 minute video. You can see this. Parallelly, you will be getting some wordings also. You can just see this. It's a very nice video, which is about the lightweight concrete, pervious concrete. See here, this is the no fines concrete, no aggregate, no fine aggregate. That is the this is the advantage of using such things, because you see nearly 600 to 900 gallons of water was poured on the paved surface, and you see how nicely that concrete behaves. Everything, it has a very good absorption capacity. So thereby, if suppose when there is a heavy downpour like this, what it happen? It acts as a groundwater recharge technique, so that will be recharged. The groundwater will be recharged. Say one some 3D view in a block form that was shown in that video, right? So that is the advantage. And last slide to say about how this lightweight concrete has come into existence is, because normally when I study about the self-made special concretes, I will be very happy to search for the history also. How did they found and all these things, because naturally I love history. What is the past, how they have done this, because I am very fond person. So in that way, I have collected some source. First and foremost, they found this lightweight concrete in the port of Kosa. This is somewhere in the 273 BC, and this port of Kosa is somewhere near Spain. But this is a seashore area. What happened? They used some lightweight concrete using these volcanic materials. So these wordings is really interesting. That's why I put this slide as a last slide. These early builders learned that the expanded aggregates were better suited for marine facility than the locally available beach sand and gravel. You see this? So that volcanic materials were very good. It was highly resistant also, it seems. Then they went 25 miles, that is 40 kilometers, to the northern east of that port of Kosa, to the quarry of the volcanic aggregate at the Volcano complex for the use in the harbor. They used in the harbor for this in this port. That is why it is called as Port of Kosa. That place name is Port of Kosa. Um, because Spain and everything, those days they used to do. Spain is in the seashore area only. You know, if you see in the, it is almost in the western region of the Europe country. So this that will be surmounted with the Arctic Ocean and this thing Pacific Ocean. So that is the thing. So if you see this, the broken shards of calcinated clay versus was also used in years. The first usage of manufactured aggregate. Then for the two millennia means 2000 years. They have withstood the forces of nature with only surface abrasion. That is the key here. Normally, the seashore structure, whatever the ports, harbors you built with conventional concrete, it will get eroded very easily because of the ingress of the seawater. The waves hits and comes, and the force will be very high. It will get eroded, but it has withstood for 2 millennium. That is for 2000 years. It is still long lasting. So that is one key here. So that is how the lightweight structure has come into example. So they only became obsolete because the situation of the harbor. Because of the siltation of the harbor. The excess of silt deposit when it has burned, it has become obsolete, because that is quite normally if the silt is deposited on your concrete, it will expand. So that is how it got degraded, but not because of the erosion or abrasion. So this is the key. So this is the first sustainable case study of lightweight concrete, which was experimented in 273 BC in the port of Cosa, which is located at Spain. Okay, so this is the my final slide, and thank you very much for your patient hearing. Now I open the session for discussion, if any. So if you have any questions, let me see if there is any question in the chat box. Sir, PPT is not visible continuously. Please ensure that. Why? PPT, maybe your net connection should be the thing. Okay, Raj Kanan, kindly pin our Karthikeyan Jaykumar sir. Okay, thank you for viewing my YouTube. Thank you, Raj Kanan. And anyway, I will post this in my YouTube channel also. This video, I will because this is live. I came to know this is live streaming in YouTube also using this using Paavai YouTube channel. but however, I will download that video and I'll post in my channel also. Okay, Vijay Anand, history is informative, sir. Okay, naturally, history we should never forget because more clues you will get that. Jamila Kasim, please share the PPT is possible. Video itself I will share, don't worry. Not only PPT. Syed Mayudi, can lightweight concrete can be used in commercial building? Yes, you can use. Why not? But please ensure that you are getting above 20 M20 grade concrete should be used. Then you can use for commercial building because RCC it comes as a structural material. So please ensure that that thing only. It is very useful if you use lightweight concrete in commercial purpose. You can use it and kindly send the link. Yeah, that's what the link you mean. My video link only. No, I will give you Siddharth Jain. So just if you want to see my YouTube video, again I will tell you, type Karthikeyan Jayakumar. Karthikeyan space Jayakumar. So you can find more videos. The same video which was played also, it is there in my day 10 lecture which I conducted a webinar last month. So in that more information, 10 days session was there. So you can see all those things. Informative session, sir. Thank you. Thank you, Vimal. Yes, sir. Okay, wonderful presentation, sir. Mukesh. Thank you, Mukesh. Uh, then Abhinaya. Thank you, sir, for wonderful presentation. Can we use lightweight aggregate concrete as economical by using? Yes, you can use. See, that's what I'm telling. When you want to use your lightweight concrete, if you want to enhance the strength, see, I told initially, up to 70 MPa we were able to get. But beyond 70 MPa, it is $1 million question. Because whatever, so you should have some highly mechanized with high mechanism. Because when it is performing with 20 MPa and if you are making 70 MPa, that is highly remarkable. So you no need beyond that. Why do you want beyond 70 MPa? It is more than enough. They are using for high performance pre-stressed, lightweight pre-stressed concrete structures also. They have tried and it is successful. But only thing is you have to strictly adhere the quality control. You can use Abhinaya, no, absolutely no problem. Using Pasalana, it will enhance your properties of concrete only. Mukesh Srimali, is it useful for high-rise building? Yes, most of the lightweight high-rise buildings are lightweight because when you are going for the stories, in the top stories, the number of columns will be reduced apparently. Suppose in the 50th floor, you no need to give all the things. The size of the columns can be reduced effectively. You no need to keep 300 by 500 or you no need to keep 750 by 750. You can make it 500 by 500. So that based on the design, how it is, right? Okay. Then Sivaraman Rajendran, what is the highest strength that can be achieved? Everybody is very concerned with the strength. I told no up to 70 MPa. Beyond that, it is a question mark. You have to do research. Still, it has not come into existence because getting 100 MPa, 70 MPa itself is very challenging. You have to work a lot in the concrete lab. Justin Raj, why not we choose latest fasting materials like Fevicol, Feviquick instead of cement for lightweight? Very good question, Justin Raj. But how much quantity you will? Just tell me if you. I want to use the Fevibond to paste in some of my thing. What is the cost of the Fevibond? If you are affordable to put if you are affordable to take some 1 kg of Fevibond, 1 kg of Fevibond will be 10,000 rupees because normally when you take a small paste with just 5 ml Fevibond, it is charged 15 rupees. You will be knowing it. So 5 ml is what? It is after like 5 grams. 5 grams is 15 rupees. So how much you will be using? And moreover, if you use Fevibond and everything, it will quick set. By the time you are pouring, before you pour, it will get stick into it. So if you want to experiment and if you are very rich enough, Justin Raj, you can go for Fevibond construction. No problem. You experiment and you see. I think you are a very rich guy. Very phenomenal question. So far, I haven't heard this from my students. Nobody have asked such a good question like this. You have asked. Okay. Then Vijay Anand, is there any availability of lightweight aggregate in market, sir? That's what I'm telling. In market, they will charge very heavily. They will say 1 kg of aggregate will be like 40 rupees, 50 rupees. Are you able to afford? That's why I'm telling you, artificially prepare. Make it in pelletized form. Do the sintered lightweight aggregate preparation. Lightweight concrete can be made in RMC. Yes, we can make. It is possible. Justin Raj, your opinion, sir, please. I gave my opinion already. Okay. It's Duari. Just subscribe to your YouTube. Thank you, Duari. Okay. Adolf Marvel Raj. Design criteria of no fines concrete is in small structure like single floor home. Will it be suitable? See, no fines concrete, you can use it for pavements exclusively. Then for some retaining walls where the water has to still self drain, because those things the water should not stagnate on it. If you use no fence concrete for your home roof, all the water downpour that comes and it will fall into your home, and your home will become like a small ocean. You will be submerged in the water only. Okay, don't use no fence concrete for your house. I am telling this for only pavement and other purpose. Okay, don't, please don't get confused, Adolf Marvel Raj. Then Mukesh Srimali, cost of concrete per meter cube. Just calculate, see the current market rate, and now for conventional concrete it is around 6,500 to 6,500 rupees per meter cube. You just calculate for your lightweight concrete. It should be fairly less. But if you make your own preparation, uh, what is the high strength that can be achieved using lightweight concrete? Already I told no, Sivaraman. Again, don't need to post that same question. Okay. Next, Sanjay Patil. Does the durability of concrete get affected due to lightweight? See, that's what. Corrosion. Because it will be due to its lighter weight, it has possibility to penetrate. So what they are telling is increase your cover size apparently so that you can safeguard. So if you go with the nominal thing, it is a question mark. Okay. So that is the only thing. Vijay Kumar, thanks. This is thank you, sir, for this informative session. Thank you. Purushothaman, same here. Thank you. Um, Sanjay Patil, does the durability of concrete gets affected due to lightweight? I told already. If you adhere the strict things, yeah, strict quality control, it will not affect. Like maintaining the cover size, maintaining the water cement ratio, it will not. Otherwise, it will, because it is a very good fire resistant than that of your conventional concrete. Kameshwar Singh Nim, very informative topic, sir. Can we say that lightweight aggregate is good in terms of durability also? Yes, it is there in your hands. You have to maintain the quality. Brijesh Savlia, nice presentation, sir. Which is more effective to make floating concrete, Pumice or Nika? See, these are all certain brands. Okay, Brijesh, these are all certain brands. See, floating concrete, I mean to say, go for some foam materials. Pumice and other things is a lightweight aggregate where the bulk density itself will be like 600 or 700 kg. When you use your cement fine aggregate and if you bring it to it, the density will touch like 1100. So it will not float, definitely. So you have to use some foaming agents. Then only you can use. Deshuttering period of homework, same as it. But only thing, check for the strength. Better to keep 21 days rather than 14 days. Arprit, please provide feedback link. Okay, that will be given by your coordinator. Everybody is asking for feedback link only. Okay. Then Sanjay Patil, concrete cost of concrete reduces. That depends upon the aggregates. How you purchase. If you buy in the market, it will be very high. Normally, I don't suggest to buy in the market. I told no. A simple example, 40 rupees. So that is not a correct thing. So better you manufacture it by your own. Mukesh Srimali, which waterproofing chemical is used in fan? You want me to tell the brand? I'm sorry, I cannot tell the brand. You know the brand very well, which is very famous. Because why I am telling is, since this is a common forum, then the people, because I'm going to publicly publish this video, so if I concentrate on one particular brand, then other brand people will be coming and fighting with me. Sir, you are working with our brand and why are you telling only our brand? So I am not here for marketing. It is in your hands. You experiment, you see how compatible it is. So when you are going for waterproofing chemical rather than going for liquid, you please use it in powder form. That is very good. That is very effective also. Don't use it in the liquid form. Liquid form sometimes, yeah, when you overdose and everything, it will create some adverse effect. So better do it in the powder form. You mix it with the cement and do like a traditional how you do it. Mukesh Srimali. Difference between normal weight concrete mix and lightweight concrete mix. The difference is only the density varies. So your particle size, specific gravity, and everything will be there. You will not get 1100 kg per meter cube. Here you will get only 300 or 400 kg per meter cube. Okay, it will be, even it will be less than that. Even if you use 300 kg per meter cube of cement or 320 kg per meter cube of cement, the coarse aggregate will be only 400. So don't get surprised. So when you add only like that, then only your yield value will end up with 1500 or 1400. Otherwise, you will not get the lightweight. Okay, that is the only thing. Uh, then Sivaraman Rajendran, can we use recycled hollow PVC balls as lightweight material? Yes, you can use. See to it, the bulk density should be within. Normally, for bulk density for your conventional aggregate will be like 1850 kg per meter cube. It will be ranging from 1650 to 1850. So any bulk density which is less than 1650, you can use that. That will be like a lightweight material. So preferably go with 1150 kg per meter cube as a maximum if you want to achieve lightweight. Mukesh Srimali, durability of lightweight concrete and normal weight concrete. Already answered to this question. Then Civil Naveen Chandru. Uh, which type of concrete is best for high-rise building? You can use high-strength concrete, high-performance concrete, many things. That varies. Even you can use some smart concrete. It is up to you. Okay, so based on the situation, you can select whatever. You can use polymer concrete. Okay, so yeah, you have to use Sivaraman Rajendran again, or can we use recycled PVC pellets as aggregate? That is what Rajendran I am telling you. You see to it that your bulk density of your aggregate should be within 1150 kg per meter cube. At any cost, don't exceed beyond 1150 kg per meter cube. Then you will not get lightweight. So that is a challenging task. Right. Mukesh Srimali again. Is it useful in sloping roof? Yes, you can use. I told it is for any structural construction. You can use absolutely. IS codes for designing lightweight concrete. No IS code has come so far. Only some ACI codes are there. You can take. You can see the guidelines. Is it preferable for mezzanine floor? Yes, you can use. Yeah, but you have to use some rich mortar mix and you can make it as a floor. You can make whatever it is. Kameshwar Singh Nim, sir, but I have read somewhere the depth of carbonation is more in lightweight concrete in comparison with normal weight concrete. So is it so? Then what we can do to protect it? See, carbonation depth means it is more alkaline. So if it is more alkaline and CaCO3 and if it presents the why the carbonation depth is coming is might be some lightweight aggregates will be richer with calcium. So when calcium is more inbuilt with that is CaO, so naturally when CO2 come into the picture, it gets carbonated. It becomes CaCO3. So that in that case it will be little bit. You have to see the carbonation depth. So in that way, well, you should see that it should not get affected because of this carbonation. So if carbonation comes and everything, you have to protect that. That is the only way for that. You cannot. You have to take some preventive measures and see that the concrete is not carbonated. You have to use some protective solutions over it such a way that it should not directly react with the CO2. Even if CO2 comes into the picture, you make some film like on that aggregate material so that it will not get carbonated area. So that is one thing. Sometimes it happens. So that's why I'm telling selection of materials is very important. You cannot blindly choose whatever the materials as you wish. You have to do the complete property study and you have to use. Can we use for underwater construction? No, underwater construction is again different. Sanjay Patil, you can see my underwater construction video, another guest lecture which I gave in Kumaraguru College, not Kumaraguru, NGP College, Coimbatore. In that I have told the guidelines of underwater construction. You cannot use lightweight concrete for underwater construction. That is a different phenomenon. You will be using a completely different chemical. You without anti-washout chemical, you cannot go for underwater construction. It is not possible at all. So that is different and this is different. Don't compare that end with this here. This is totally a different platform. Anis Fatima, thank you, sir, for wonderful presentation. Thank you, madam. Any more questions? I hope I have answered all the questions, whatever it was in the chat box. Any more? If you have any more queries, you can ask me, or else we can wind up. Yes, Murthy.
சார் இல்லை சார் அவங்க என்ன வெயிட் பண்ண சார் ஏதோ கேட்குறாங்களான்னு.
என்னப்பா புரியல.
இல்லை இல்லைங்க சார், நாங்கள் ஆர்கனைசிங் சார் பாவை.
Okay. I know that. That's what.
Yes, no question, sir.
That's why I called you whether we can finish it up because you have introduced me. I know you.
Yes, sir. Okay, sir.
No? Yeah.
Participants, if you have any queries, you can ask.
If not, we will wind up.
Okay, sir. Shall we wind up, sir?
Okay. Thank you very much.
Thank you, sir. Thank you for your wonderful session, sir.
Okay. So,
Okay.
shall we leave now?
Yes, sir. Okay, sir. Please.
Okay, thank you.
Oh. Thank you, sir. Thank you so much, sir.